So today we will continue with the Pyspark part and we will be doing the machine learning part. So I'll open Colab and then I'll open the notebook that we were using yesterday. So it's the big data IPYNB file. And then the next thing I'm going to open is the Pyspark documentation website. So Pyspark ML. So I'll open this I'll open this website and here we have everything we need. So I can click on basic statistics and we can start from here. So let me share this link with you, then give you 2 minutes to set up your notebook, then we can proceed. So this is the website I'm currently looking at. Okay, so we can proceed. So here you can see for Pyspark ML, we have different languages that we can use. So you can use Python, you can use Scala, you can use Java. So for us, we will be using Python. So on basic statistics, you can do things like correlation, but I won't do the correlation because I guess I'll connect this first, then I'll click on runtime, then run all. I won't do the correlation part because you can do this using SQL and it's quite easy when using SQL. And then hypothesis testing, you can check that. Then summarizer, you can check that. So we don't basically need this as this is just the basics part. So what we need to do is we need to look at this part here where we have extracting, transforming, and selecting features. So the first thing you can check is the standard scalar. So how do you use the standard scalar in here? And another thing you can check here is hot encoding. I've shown you hot encoding in ML. So how do you actually do it here? And the last thing you can check in this site is index to string. So how do you convert categorical columns to be numerical? So those are some of the things we can do. Okay. So let's go back to our IPYNB file and confirm if everything is running. So I see this is taking time to run. I have to confirm I've got all outputs. So here, what we are going to look at today is ML. And for us to do the machine learning part, we have to get a data set that is usable. So what I'll do is I'll open my GitHub account. I believe there is a data set I had uploaded there that we can use for today's class. So I'll open ML may intake And then we have the shopping trends notebook here. I want to confirm what is in this file. Yeah, so we can basically use this for our machine learning task. So I'll share this link with you. So I'll click on row and then I'll copy this link. So I'll share that link with you in the chat section, and then we can import this data into our Jupyter notebook over here. So this is my data link. So I'll create a variable called data link, and then I'll create that. And then to read this data, I'll copy the code that we have up here. So this will be my df2, or maybe I can say ML data. Being equal to that. Then here where we have content, I'll type in my data link. So let me run this, and then we can confirm if we get the data. So we don't have the data set here. So for us to download this data, so first let us load it into a pandas data frame, and then we can store it into our database here, because I don't want us to download this data directly for you guys. I want you to maybe get this data directly from GitHub. So I'll have import pandas as pd. Then our df should be equal to pd.read underscore csv. Then I'm going to paste in that link there. And then I'll save this data. So df.to underscore csv. Then I must give it a name. So this will be the shopping underscore data dot csv. Then lastly, I'll specify my index should be equal to false. Let me run that, and then we can see what we get. Let me import this data again using pandas, and then we can confirm the structure of that data. So if I check my files over here, you can see the data set is now in here on my file path. So I can say my df should be equal to pd dot read underscore csv. Then I pass in my data link, and then I can have df dot head. So that's what we have. So the data is actually good looking. Then I'll comment this out. And the last thing I'll do is I'll load the data set here. So now we have the data here. So I'll give you 5 minutes to work on this. So the data importation, and then we can proceed. So at 8:23, we proceed on with the next part, which is maybe trying to fit an ML model to this data, whereby we will have to convert these categorical columns to be numeric, and then we will have to choose our target column. Yeah, anyone with a question? Okay, so I guess I've zoomed in a lot, Dennis. So this is currently at 175%, but that's at 200% zoom. Hope you can see the code clearly. I can also share it in the chat section for ease of work. Yeah, so I've shared. I'll give you 5 minutes to work on that. Yes. Yes, Jesse.
So there's that index you see post,
Just a minute. Yes, there is this index part. Yes.
and that part of data link, the header is true.
Yeah.
So what does those two mean?
Okay. So if if I don't specify my index to be equal to false, then what pandas does is it creates another column here, which has which is unnecessary, and that column will be filled with values of 0 till maybe the last index that we have in this data. So it creates an index column. So when I specify index to be equal to false, then pandas would create that new column. And then here where we specify header being equal to true, it means that our CSV has a header. So when Spark is reading this CSV file, then it will have to skip the first row and make it the column headers. So have you understood the use of header being equal to true and index being equal to false?
Yes.
Okay, that's great. So hope you are all done with that part and we can proceed on to the next part. So the next part will be the machine learning part. So if we go back here where we have our ML part. So I'll click on maybe classification and regression, and maybe we can pick logistic regression. And these are some of the steps we follow in creating our model. So first of all, we load the training data. After loading the training data, we instantiate our model. Then we feed the model to the training data. And then we print the coefficient of the model and the intercept. So if it's a multinomial kind of classification, what we usually do is we specify the family of the model being equal to multinomial, and then we fit the model. So for us, what we are supposed to do here for today is first of all start by encoding our data and maybe picking some columns here that we will use for this class. So let me open our code work. So I'll click on open folder and I'll open our class notes. So I believe we've used this data before, and maybe I'll check logistic regression. So this is where we've used this data before if I'm not wrong. So here we have attention. If I scroll down, I think, so it's not here. It's on linear regression, I guess on predicting the price. Let's scroll down and check. So it's not here. So we'll have to do this afresh again. So first of all, what we have to do is we have to define our problem statement. So these are the columns that we have. So we have the customer ID, so that's not relevant. We have age, gender, item purchased, category. We have purchase amount, location, size, color, review rating, subscription, status, payment method, then shipping type, and all those columns that we have there. So what I'll do is I'll pick maybe 4 columns. So 2 numeric and 2 categorical. So this is just for demonstration purposes. So I'll pick the age column. So we will have age. Then we will have the item purchased column. Again, which other column will we pick? So purchased amount will be our target column. And the kind of task we will be dealing with will be a regression kind of task. So this is our target column. And then which other column? So this is categorical, numeric. Let me pick another numeric column. So I'll pick the previous purchases column here. So that's another numeric column that we will be using. And then lastly, I'll pick the so let me pick the payment method here as another categorical column. So those are the columns that we will use in this assignment. So let me remove this, create a text column here, and define our problem statement. So these are our data features. So age is a feature in the data. Item purchased is another feature. Payment method is another feature. And then purchase amount is our target column. So what we are doing here is we are creating a regression model to predict purchase amount. And this time round, we are not using linear regression. So we are using a model from Spark that is for regression. So I'll click on classification and then I'll check on regression. Then I can click on linear regression using Spark. Yeah. So before we do create our linear regression model, so the first thing we need to do is we need to process our data, because already we know that this data has numeric and categorical columns. So for us to do that, we need to import a library that will allow us to select columns that we need. So I'll have import Pyspark dot SQL dot functions. So these are functions that will help us in selecting columns that we need. So import Pyspark dot SQL dot functions. So that's what we need. And then the next thing I'll do is I'll create my data. So the data that I'm going to feed to my ML model. So here what I'll say is I'll add a comment and say I'm selecting my data features. So what's our data frame name up here? So we have ML data. So we will have our data being equal to ML data dot select open brackets, and then in here I'll type in f dot call. So this is the first column that I'm selecting, and the first column that I'll select is the age column. So I'll type in their age, then dot alias, so you must give it a name, then age. So that's my first column, then comma. So I can copy this code that I've written here, paste it down here, comma, so that I can get the columns that I need. So here we have 1, 2, 3, 4, 5 columns. I'll pick the previous purchases amount here, and then I'll paste it in there. Then I'll pick the payment method, and then I'll paste it in here. And then we have which other column? Item purchased column. And then I'll paste it in here. And then lastly, we have the purchase amount in USD column. So that's how we basically select our columns. So another thing we need to do is we need to specify the kind of data we are working with. And this is for maybe numeric columns. So for example, for purchase amount, I'll add something here, maybe dot cast. Then I'll cast this column as a float. Then I can copy this and paste it into the numeric columns. So previous purchases, and then the age column, I can have it as a float also, because it will only add an extra 0 at the end instead of having it as an integer. But we can also make this an integer. So I'll type in int. And then what we can do is I can type in data.show for us to see the kind of data we've created here. Yeah, so this is our data set. So go ahead and copy this code. So I'll give you 5 minutes to do so, and then we can proceed. So you can see selecting columns in Pyspark is somehow a little bit different as compared to Python. Let me share this code in the chat section before we proceed. Yeah, so I've shared it. So we can proceed. So you can copy this and then we can proceed. So the first thing we will do is we will convert these categorical columns that we have here to be numeric. So once you are done with that, Okay, so hope you are done, so that we can proceed, and hope you have your sample data set here. Okay, so let's proceed. So the first thing we will do is we will do the data encoding. And to do the data encoding, we have to use a library here that is called string indexer. So we will have this importation. So from pyspark.ml.feature import string indexer. So this is the library that we will be using to 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 convert our categorical columns to be numeric. Then I'll type in my indexer here. So this will be my indexer 1. So indexer 1 will be for converting this column, which is the payment method column. So I'll have my indexer 1 being equal to string indexer. Then you'll open brackets. Then you'll specify the input column. So here we will have input call being equal to payment method. And then again, we have to specify our output column. Okay, so we will have output call being equal to the same column name that we had. And then we will have our indexer 2. So I'll just copy what we have up here. So this is my indexer 2. And indexer 2 will be for converting these item purchased column to be numeric. So input column here will be item purchased, and then the output column will be also item purchased. So I'll have to change these to indexer 2. Okay, so after creating those, what we do again is we feed this to our data. So I'll have my data being equal to indexer 1 indexer underscore 1 dot feed, and then I'll feed this to my data. Then I'll transform my data again dot transform. Then I transform my data, and then we will do the same thing for indexer 2. And then what we can do after doing that is we can check our data. So we will have data.show. So let's run that and see what we get. So unexpected keyword argument output call. Okay, so let me check that and see where the error is coming from. If we get errors, we can also again refer to these websites. So what I do is I just pick these, go back to this website, and then search for string indexer. So not found. We have that part. Let me find it. Yeah, so here we have our string indexer. Let's check a code example. So this is what we have. So we specify the input column and the output column. So let me paste that code here and see if what we have up here is same to what we have in the documentation side. So I'll copy that and then I'll paste that there. Then I'll paste that there again. So what I can do is I can change the column name to payment method. Okay, just a minute. Payment method index. And then this can be item purchased index. And then we can run our model again and see if we've got if we will get an output. Okay, so we've got an output. So here we've got the payment method index and we have the item purchased index column. So again, what we have to do is we have to select those columns. So I'll copy this code that we have here and then I'll paste it down here. And here where we have payment method, I'll change it to payment method index. Then cast it as a float. And then here we have the item purchased index again. And I'll cast that as a float. Then I can run these to show what I have. Okay, so here I'll have to change my ML data to data. Then I can run this again. Yeah, so here we have our data, which is all numeric. So first of all, I'll give you 3 minutes to work on this, and then I'll give you 2 minutes to copy the code that you had up there and customize it to this. So we've covered a few more things today. We've looked at how we select columns. We've looked at how we convert numeric columns to how we convert categorical columns to being numeric. And here we have the output. So the last thing we will look at today is how we create our features vector before fitting our ML model. Then tomorrow we will proceed on to the ML model fitting part. Yeah, so at 8:49, I'll stop sharing this code and I'll share this so that we can maybe summarize what we've covered for today. Okay, so I'll share the next code part, and then I'll give you again 3 minutes to work on this. For those who are not yet done with this code part, let me share it in the chat section. So you have it there. So I'll give you another 3 minutes to work on this, and then we can work on summarizing what we've done for today. Okay, so let's summarize what we've looked at for today. So we started up here, and the first thing we looked at is this Pyspark functions part. So from Pyspark SQL functions, we have these F, which is the functions part for Pyspark, which allows you to select columns, then cast them as any data type you want them to be in, and maybe give them a name. So for example, .alias part gives this column age the name age. So if we never specified the alias part, then the output that we will be getting here will be something like C_0. So things like that. And after doing that, after using the functions part, we went ahead and looked at the string indexer. So remember in sklearn, what we usually use to encode our data is one hot encoder or the ordinal encoder library. So ordinal encoder library is somehow similar to what we have here, which is the string indexer. So it doesn't like add more additional columns to your data, but what it does is it adds numbers to that specific column. So for example, for the payment method, so credit card will be converted to 0, bank transfer will be converted to 5. Then for example, here where we have debit card, you can see for debit card, we have the number 4. For PayPal, we have the number 3, so and so on and so on. So that, for example, in row 1, you can see we have credit card. And in this row, we have credit card. So anytime we come across the credit card value, then it's replaced with a 0. So something like that. And that's how the string indexer works. So the only disadvantage that you have here is you have to specify each column individually, unlike when we use the ordinal encoder. And then after doing that, yeah, the next thing we were to do is create our features vector, but let us do that in our next class. So let me stop there for today. If you have questions, you can ask. I'll go